get stuff done when you need to, but it gives me the freedom to not have to worry about some of those issues, you know. All right, so let's see. I think we're recording now. I want to make sure the mic is on. Yes, it is. Javier, can you hear me? I just want to make sure you can hear the mic. I know the screen looks a little off right now, but yep, okay, you can hear. Good. Perfect. Okay. So, all right, guys. So today what we're going to do, y'all, we're going to go through 6.1. The homework, y'all, for 6.1, again, is not due Monday. It's due the following Wednesday, which for us is going to be on the 20th. That's when the homework for 6.1 is due, okay? And the main reason I'm making it do that is because between now and next Monday, what I really want you to worry about is the test. But, you know, you want to knock out 6.1, you know that you're always welcome. Okay, so let's see. 6.1, y'all, is applications of right triangles. So in 6.1, what we're going to be talking about is how do we solve a right triangle? And when I'm talking about solving a right triangle, what we're looking at is, can we find the measurements of each of the sides? And can we find the measures of each of the angles? So one thing we know is because we're dealing with right triangles, we already know that that angle is going to be how much? 90 degrees, right? Okay, so out of the 6 parts, we already know one of them. We're really going to be finding 5. Tell me, John. And there you go. So all the angles right here, y'all, have to add up to 180. That's one of the properties of triangles. You take all the angles inside a triangle, add them up, you get 180 degrees. And then obviously we have the Pythagorean theorem. And then we have how we define our trig functions, right? So remember we said the other day, that's not how you do it, Omar. Soka, Toa, right? Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, right? All right, so let's see if we can figure out this first problem. And hello, and it says solve the right triangle, find the lengths to one side, the lengths of sides, I'm sorry, to one decimal place. Okay, so guys, let's think about it this way. We're going to write out the angles. We have angle A, angle B, angle C. We already know that angle A is 28 degrees. Do we know any of the other angles here? C? C is how much? Okay, how would we find angle B? Okay, so if we already know that when we add up all the angles together, we end up with 180, right? And so John says this is 28. We don't know B. We know C is 90 degrees, and that's 180. So 28 and 90 should be something like, everybody agree, 118? Okay. And then can we subtract 118 on both sides? And you're coming up with 62. All right, oops, 62. All right, so we got angle B to be 62 degrees. We have the measures of all the angles. What we need to find now, y'all, are the measures of all the sides. All right, so let me ask you a question. If we wanted to use, say, angle A, and we wanted to have a relationship between this little side A and the hypotenuse, what could we use? Sine, right? So we would say the sine of A, which is the sine of 28 degrees, is equal to little a over 14.8. So now we want to find little a. Aren't we just going to multiply both sides by 14.8? So that those will cancel. So we'll have 14.8 sine of 28 equals little a. So let me see. Let me get the calculator going here. And let's see if this is going to work. So first thing I'm going to make sure, guys, is that I am in degrees, right? And so I'm not. So I'm going to come over here. Let's make this into degrees. Okay. So guys, if you're doing this on your app, make sure, or your regular calculator, make sure that your calculator's in degrees. Otherwise, you're going to end up with some jacked up answers, okay? So let's quit that. Okay, so we're going to go 14.8 times the sine of 28 degrees. Hello. And we're supposed to round to one decimal place, y'all. So would you say 6.9 or 7? 6.9, right? Okay, so cool. So we got A is 6.9. We're not dealing, 6.9, not 8. We don't have any units here, so 6.9 what? I don't know. 6.9 units. Okay. Now, let's see if we can do the same thing here. Now, we want to find, we already found little a. We already know what little c is. We need to find little b. What could we use to find little b? Cosine? Or we could use the Pythagorean theorem. So, guys, we actually have a couple of options. John says we can use the cosine of 28, or we can use the Pythagorean theorem. Let's stick with cosines, okay? So look, let's go cosine of 28. Remember what we said the cosine is? It's the adjacent over the hypotenuse, so it's going to be b over 14.8. And just like we did before, aren't we going to multiply both sides by 14.8? So we're going to end up with b equals 14.8 times the cosine of 28 degrees. And let's see what we get for that. So we're going to go 14.8 times the cosine of 28 degrees. And to one decimal place, what would you guys say? 13.1, good. And we got it. So this, when they say solve the right triangle, this is what they're asking us to do. They're asking us to find the lengths of all three sides and the measures of the three angles. Okay. So guys, a little while ago right now, when I asked you, how could we find b? John says, well, look, we can do the cosine of b, or the cosine of 28 is b over the 14.8. We could also use the Pythagorean theorem. Is there any other trig function we could have used? Did we ever find out what angle B was equal to? Yeah, we could use tangent also. Did we ever find what angle B was equal to? This was 62 degrees. Let me ask you a question. Could we have said the sine of 62 is equal to this side over that side? Yeah, we could do that. Okay, I agree we could also use the tangent because the tangent is the opposite over the adjacent, right? Now, the only thing I am going to say, y'all, when we found the measure of angle A, or I'm sorry, side A, didn't we round this? Like we stopped at 6.9, but it was really 6.9 and change. Typically, when we do these types of problems, we don't want to use any approximations. Like I don't want to use a side that I approximated to get my answer. But think about the number 62. We didn't approximate anything there, right? 62 was exactly 62 because we added 28 and 90, we subtracted it from 180. So when you're doing these problems, you really have a lot of freedom in how you do these problems. Typically, like the general idea though is don't use, if you can avoid it, don't use an approximation in finding a second piece. You know what I mean? So if I'm going to find, I'll get with you right now, John. If I want to use, I would probably avoid using the tangent because it's going to be b over a, and a we decided we were going to round that to 6.9. Does that make sense? Tell me, John. That's what we wrote right there. Okay, say it again now.
So instead of writing the approximation of A, which would be 6.9, you have 14.9.
Sign. Okay, you're using that. Yeah, you could do it like that too.
So you don't have to do anything.
That works as well. Yeah, definitely. Yes. So let's take a look at number 2. Same kind of problem, y'all. Solve the right triangle. Round the measurements to one decimal place. Let's take a look here. So remember, we need to find a couple of things. We need to find angles A, B, and C. And we need to find the little sides A, B, and C. So right now, let's figure out what we know. What do we know from this triangle? Do we know any of the angles? We know angle C is 90 degrees. Okay, we don't know A or B just yet. Do we know any of the sides? A is 9, and C is 20. Okay, so let me ask you a question. What do you think should be the first side we should try to find here? Let's find B. Okay, Y'all agree that we can use Pythagorean theorem? So we can find b? Okay, so let's go a squared, 9 squared, plus b squared equals 20 squared. What's 9 squared? 81, good, plus b squared equals, what's 20 squared? 400, right? Okay. How do I get rid of my 81, y'all? Subtract it on both sides. Anybody got a calculator? Do y'all know what 400 minus 81 is? I want to say it's 389? 319, oh, 319, sorry. Oops, where's my eraser? 319, okay. So now to find b, we're going to take the square root of 319. Anybody know what that is? Grab a calculator, turn it on. Come on, turn it on. 319. 17 and change, right? Okay, so guys, remember, we're still rounding to 1 decimal place, right? So if we're rounding to 1 decimal place, would you say 17.8, 17.9? 17.9, okay, so we're going to round here 17.9. So right here, y'all, I'm going to write 17.9. Okay, so we found our measure for angle B, okay, or for side B, I'm sorry. Now, we need to figure out how we can find the angle A and how we can find angle B. So think about the sides that we were already given. We were given this side here, and we were given this side here. If I wanted to use a trig function for angle A that described the opposite over the hypotenuse, which trig function would I use? Yeah. So couldn't we say that the sine of A is equal to the opposite, which is 9 over 20? And then if I wanted to find angle A, wouldn't we say A is equal to the sine inverse of 9 over 20? Okay. So again, here, y'all, I'm going to use my calculator. I'm going to go second sine inverse, right, of 9 over 20. And to the to 1 decimal place, would you guys say 26.7 or 26.8? 26.7. Okay, so we found angle A to be 26.7 degrees. Okay. And how could we do this for angle B? Could we do something similar for angle B? What would we have to use if we were going to use, I'm sorry, for angle B? Yeah, couldn't we say the cosine of B is equal to the adjacent over the hypotenuse? So that then B is equal to the cosine inverse of 9 over 20? So if I pull up my calculator again, and I say, look, let's go cosine inverse of 9 over 20, hit enter. Would you guys say 63.2 or 0.3? Yeah, 63.3. And we solved our right triangle, right? We have all 3 angles, and we have all 3 sides. So far, what do you think? Are we doing okay so far with this stuff? Making sense? Yeah? All right. So squiggly lines just means it's approximately, right? It's an approximation. It's kind of sort of equal to, but not exactly. All right, so let's go ahead and go on to the next one here. And I'm looking here at number 3, y'all, and it says, a surveyor stands on level ground 100 feet from the base of the lighthouse. He measures the angle from the top of the lighthouse to be 18, from the ground to the top, I'm sorry, from the ground to the top lighthouse to be 18 degrees. So let's take a look at what's going on here. We got something like this, okay? Do we know how far it is from here to here? That's 100 feet, right? Okay, and we know that this angle down here was what? 18 degrees. Rounded to the nearest foot, what's the height of the lighthouse? So we're trying to find that distance right there, right? Okay, so is there any trig function for, say, 18 degrees that involves the opposite side over the adjacent side? I mean, tangent, right? So we know the tangent of 18 degrees is equal to h over 100, right? So just like we did before, couldn't we multiply both sides by 100? So we know 100 tangent of 18 degrees, this 100 and that 100 are going to cancel, is going to be equal to h. And so now we're going to approximate this again. So we're just going to go 100 tangent of 18 degrees. And guys, would you all say the height is, oh, we got to round to the nearest foot. So is the nearest foot 32 or 33? Okay, but hold on, remember, we're not rounding to the nearest tenth and then rounding to the nearest foot. We're rounding to the nearest foot. So 32, right? Because I'm only looking at what digit, y'all? I'm only looking at the 4, right? I'm not really concerned about what's happening after that. If we're rounding to the nearest foot, we're going to round to the nearest whole number. So yeah, we'd say 32 feet. Good. Excellent. All right. So we're making pretty good headway here, y'all. This is good. Let's take a look at the next problem. Very similar, just some slight differences. So I'm going to do this just so we focus on this part. And it says, a surveyor stands on level ground 90 feet from the base of the lighthouse. And it says he measures the angle from eye level to the top of the lighthouse to be 28 degrees. Okay, so let's see what's going on here. We got something like this. We know that this angle is 28 degrees. We know that this distance from here to here is 90 feet. We are trying to find the height of the lighthouse. So we're trying to find this whole distance right here. Let's call it H. Okay, but I'm going to call this, oh, I don't know. Let's pick a different letter. Let's pick T. Couldn't we say the tangent of 28 is the opposite over the hypotenuse? So I would say the tangent of T, or not T, but the tangent of 28 is equal to T over 90. So we can multiply both sides by 90. This is 90 times the tangent of 28 is equal to T. And then we could solve for T, right? So I'm going to pull my calculator up again. Let me move this over here so we can see what's happening. 90 times the tangent of 28 degrees. And to the nearest foot, y'all, would you say 47 or 48? 48, okay. So T is 48. So we know that the distance from here to here, see if I can make it a little bit better. We know that this distance right here is 48 feet. But we're trying to find the entire height. How would we find the entire height? Add 5, so 48 plus 5. What's that, 53? 53 feet. Okay. All right, all right. Let's take a look at another one similar. And let's take a look here. Let's see what we got. It says, to determine the height of a window in the top of the lighthouse, 2 measurements are taken from the ground, 90 feet from the base of the lighthouse. Okay, so first thing I know is this piece right here is 90 feet. Okay, the angle of elevation from the ground to the bottom of the window is 36 degrees. So I know that this part right here, y'all, is 36 degrees. And then it says the angle of elevation from the ground to the top of the window is 42 degrees. So wouldn't that tell me that this bigger angle here is 42 degrees? And now it says can we find the height of the window to the nearest foot? What we're really trying to find, y'all, is that distance, isn't it? Isn't that what we're trying to find? The height of the window? Yeah, the height of the window to the nearest foot, right? Let's see. How do you think, or the height of the window? Let's see.
You find the length of the opposite or the black and the red and the
Okay, so let's do that. So which is going to be the bigger one? The red, right? The red triangle. So something like this, right? And so what did we say? The tangent of 42 is equal to, let's call this, I'll tell you what, we're going to go R for red. R over 90. So again, we'd multiply both sides by 90. We're going to get 90 times the tangent of 42 is equal to R. So again, I'll pull up my calculator. We're going to go 90 tangent of 42. Okay, so I'm coming up, y'all coming up 81? 81 feet. Okay. And then let's go with this triangle right here. In that angle, okay. So now we would say that the tangent of 36 is equal to, guys, I'm going to use a B for black, B over 90. So again, we'll multiply both sides by 90 again. So we're going to come up with B equals 90 times the tangent of 36 degrees. And so we'll go 90 tangent 36. And you guys say 65? 65 feet. Okay. So now we're trying to find the height of the window. Like, how tall is the window itself? This piece right here. Did you say you were going to subtract 81 minus 65? Right? Okay, let's see what it is. 81 minus 65. What is it, 16? So the height of the window, or the window, is 16 feet tall, right? Okay. Figure it out. Good, 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 good. Okay, guys, there is a second part of the question. From the given information, can we determine the height of the lighthouse? Can we actually figure out how tall the lighthouse is? How would we do that? How would we find that distance from there to there? The what now? Well, which one? I don't know. So I'm asking. And Luciano says yes. Right, but remember, that's only to the top of the window, right? That's only to the top of the window. Well, that, again, so look what the question says. Can we determine? What do you guys think? If you say yes, raise your hand. If you say yes, you can do it. No? Okay. No, we can't. Yeah, because there's no way for us to figure out that little piece right there, right? We'd have to know that little piece right there, right? Just like way before we subtracted, if we knew how tall it was from the top of the window to the top of the lighthouse, yeah, we would just add it to that 81. But no, we can't do it. Okay, good. That's what it's asking us if we can, and we said we cannot. John, are we good? I know you said you wanted to double check something, so I want to make sure before I go on that we're good.
Yeah.
Okay. All right, so guys, let's take a look at this next problem here, number 6, and it says an observer in a helicopter hovering 200 feet above the sea makes measurements to 2 buoys at points A and B below. She finds the angles of depression to be 44 degrees and 35 degrees respectively. Assuming the observer is in the same vertical plane as the buoys, what is the distance between the 2 buoys? Okay. All right, so let's see if we can figure something out here. Guys, we know that the distance from here to here is 200, right? So we know that. That's something we already know. And then look what kind of angles they're talking about. They're talking about angles of what? Depression. So if you remember what an angle of depression is, I'm gonna make this dotted green line a little bit bigger just so that we can kind of get the idea here. The 44 degrees is that angle right there. And the 35 degrees is that angle right there. Okay? That's what we mean by angle of depression. Okay, so let me ask you a question. If I know that that angle right here is 44 degrees, is there any way for us to find how much this piece is? Couldn't we just say 90 minus 44, right? Because this is really going to make a right angle. Okay, so 90 minus 44, anybody know? And yeah, 46. Good. There you go. That's right. Good. So we know this angle here is 46. Is there any way for us to find this angle right here? Wouldn't we go 90 minus 35? And wouldn't that be 55? Okay. So we know that this angle here is 55. Guys, remember what it is we're trying to find. The question is asking us to find the distance between the two buoys. So the question is actually asking us, can we find how far it is from there to there? Let me ask you a question. Could we figure out how far it is from, say, here to here, knowing that this distance here is 200 and this right here is 46 degrees? What trig function would we use that would describe, say, the opposite over the adjacent side? The tangent, right? So we would say the tangent of 46 degrees is equal to, I'm just going to call this x1 for right now, y'all, okay? x1 over, what did we say, 46? Over 200, I'm sorry? Over 200. And then if we wanted to find that x1, we'd say, look, let's multiply everything by 200. So we end up with 200 tangent of 46 is equal to x1, and then we can approximate that, right? So I'm going to pull up my calculator, I'm going to move it over here, turn it on. So we're going to say 200 tangent of 46 degrees. And we're going to the nearest foot. So would you all say that's 207 or 208? 207. Okay. Now let's do the same thing over here. Let's see if we can find this distance. I'm going to call this one here x2, y'all. Okay. So if I know that this angle here is 55 degrees, is there anything that relates, again, the opposite over the adjacent? Tangent again, right? So now we're going to say the tangent of 55 degrees is equal to x2 over my 200. So again, we'll multiply both sides by 200. That's going to leave me with 200 tangent of 55 degrees is equal to my x2. And so again, we'll pull up our calculators and we'll do it here, 200 tangent of 55. And you're coming up with 286? Good. Okay. And I'll tell you what, y'all. Why don't we call the distance in red? Why don't we just call it, and not x1, because we already used x1. Why don't we just call it x? Okay. So if we want to find that distance x, wouldn't we just take this number and add them together? And so 207 plus 286 was how much? 493? And I think this is in feet, so we'll put feet. Yes. Didn't we get 207 for the first one over here? Right? And then we got 286 for that one right there. So we said, look, if we want to find the entire distance, aren't we just going to take those two numbers and add them up together? So 207 and 286, I came up with 493. John, we're good now?
Yeah.
Okay. It's not giving you 493 when you're adding them?
No, I think they want to go to the
Okay. Okay. So yeah, so guys, the one thing I want to mention with these problems here, just take your time with them. You can see as you're going through them, which one of the trig functions we actually used in the last like 3 problems? Tangent, right? Guys, what helps me so much in doing these problems, I'm going to come back over here to the very, very, very top, is knowing that. What's the trig function? How is it defined? What sides am I given? Oh, I'm given the opposite and the adjacent. Hey, use tangent, right? Oh, I'm given the opposite and the hypotenuse. Use sine. Whatever it happens to be, right? But that's really how I'm able to kind of figure out, what I'm going to use here. Guys, the other thing I do want to mention, I mean, there's multiple ways to do these problems. We could have done this problem in a different manner. Okay, we could have done something different. Maybe we would have used a different trig function. Just by coming up, looking at different pieces, right? So you really have a lot of ways of doing the problems. Okay, so just if your instinct tells you do it this way, or that's your first thought, run with it. See if we can get it to work. Okay, so now next thing we're talking about here, guys, is something called the bearing of an object. And it says the term bearing is used to convey the angular relationship from one point to another. And it says the bearing from point A to point B is the degree measure of the acute angle formed by ray AB. And this part is really, really important, y'all. Always going to be the north-south line, okay? Whatever our ray AB is and the north-south line. Yes, John? Okay, say that again? Okay, so remember who we're looking at. The bearing from a point A to point B is the degree measure of the acute angle formed by ray AB and the north-south line. It says the bearing is denoted by the letter north or south, N or S, followed by the measure of the angle in degrees, followed by the letter E or W for east or west. Okay, so here's an example. Oops. Here's an example. It says, for a ship bearing south 40 degrees west, is heading in the southwesterly direction. Specifically, the ship is traveling south 40 degrees to the west due south. So look what they're saying. When it is south 40 degrees west, we're heading in the south direction. The 40 degrees is always going to be the angle measured from this to the north-south line. I'm always measuring the angle to the north-south line. Okay, so am I ever measuring this one? No, because it has to be to the north-south line. Okay, so let's take a look here. I'm just going to kind of zoom in so you can kind of see exactly what's going on. So what does north 42 degrees east look like? We're heading north, but the angle is 42 degrees. And again, it's always measured on the north-south line. Okay. North 74 degrees west. Again, we're heading in the north direction, so we're heading slightly up, but this angle here is 74 degrees. South 40 degrees west, I'm heading in the southern direction, 40 degrees measured that way. And south 69 degrees east, we're heading downward, and this angle here is going to be 69. Always going to be measured on the north-south line, okay? Every single time. Yes, they need to put something after it. Okay, so look what it's asking me to do. Find the bearing from A to B. So, first question, look towards A, look towards B. What direction are we heading in? Are we going up or are we going down? Okay, so we're heading north. What is my angle going to be? 50. It's always the angle measured from that ray to the north-south line. So it's always going to be on your, kind of like your y-axis, okay? Everybody agree that's 50 degrees? 50 degrees, since we're heading to the right, east. Does that make sense? Okay. All right, let's take a look at number 8. Look at the direction of our ray. Are we going slightly up or slightly down? Slightly up. So it's going to be north, right? Now remember, y'all, the angle that I'm trying to find is that angle right there. Okay. Anybody know how we could find that angle? 124 minus 90 degrees. Isn't that going to be 34 degrees? So 34 degrees. Are we heading slightly east or slightly west? Boom. Okay. Let's do the same thing for number 9. Look at number 9. First question. Are we heading north or south? South. Okay, so we're going to go south. Now remember the angle we're looking for, y'all. Let me ask you a question. I'm going to do it like this. Am I looking for the red or am I looking for the green? The green, always with the north-south line, y'all. Always with the north-south line, right? So there you go. If you wanted to find this angle right here, you're going to say 270 minus 220. Wouldn't this angle here be 50 degrees? Right? So we don't want the red because it's always with the north-south line, y'all, okay? So south, 50 degrees. Are we heading slightly east or slightly west? There you go. There you go. All right, let's take a look at number 10. Number 10 says, let's see. Okay, first question. Are we heading north or south? South. Okay. What angle are we looking for here? Are we looking for the 19 degrees that we already have? No. We're looking for that angle, y'all. So how would I find that angle? 90 minus 19? Isn't that going to give me 71? So south, 71 degrees. Are we heading east or west? You got it. Okay. All right. All right, so y'all look at number 11. It says find the bearing from A to B. So we're not going from B to A, we're going from A to B. And what I like about this problem is, look, they give us a hint. And it says hint, sketch a coordinate system with the origin at the point A. Okay, so remember what we're trying to find now. Look, let's take a look. Here's my coordinate system, right? This is the one that we're looking for. There's my ray from A to B. Okay, first question. Are we heading north or south? South. So we know we're going to be going south. Okay, remember what the angle we're trying to find? We're trying to find that angle right there, aren't we? Anybody know what angle that would be? 60 degrees, right? Guys, remember we said when we add up all the angles inside a triangle, it has to add up to how much? 180. We already know that this angle is how much? 90 degrees. So the other two have to add up to 90, right? So we can say 90 minus 30, that gives us 60 degrees. Are we heading slightly east or slightly west? Boom. As a quick reminder, y'all, remember the angle we're looking for is always the angle with our north-south line. Always with that angle right there. Sometimes we get confused. Oh, let me find this. Yeah, it's always got to be with that north-south line. On what now? Off the top of my head, I don't know. Yeah, yeah, it has to do something with that, but what exactly is it off the top of my head, John? I don't know. Okay, let's take a look at number 12. It says the boat leaves the marina and sails north for 30 minutes, then west for 2 hours. If the boat's average speed is 12 miles an hour, find a bearing for the return trip, round to the nearest degree. Okay, so we have a boat and we're going to go 30 minutes. How fast are we going? 12 miles an hour, right? So guys, think about it like this. Remember my basic distance formula is distance equals rate times time. And if we're going 12 miles an hour, but we go for 30 minutes, isn't that the same thing as half an hour? So what's half of 12? 6. So I know that this distance here, y'all, is 6 miles. Okay. So we were going north for half an hour. We went 6 miles. Then we headed west. So isn't that taking a sharp turn like this? It's a little crooked, so let me, still a little crooked, but you get what I'm doing. And we go for 2 hours. So let's figure out that distance. 12 miles an hour times 2, what's our distance here? 24. So we know this distance is 24 miles. Okay, we want to find the bearing for the return trip. So I'm going to call this A. I'm going to call this B. Look, I put my business right there, right? Okay, let's see if we can figure some things out, y'all. Let's take a look. Everybody agree this is the right triangle? Okay. If I wanted to, I know the angle that I'm really trying to find, y'all, is this angle right here, right? That's the angle that I'm looking for. Is there a way that we could find, say, this angle? What could we use? What's the formula, though? You got to know it, right? What's the formula? Anybody know? Tangent. Let's call this theta. So the tangent of theta is equal to the opposite over the adjacent. So that's telling me that theta would be the inverse tangent of 6 over 24. So let's turn this thing on. Let me clear that out. Let's go second tangent inverse of 6 over 24. Okay. And we're going to the nearest degree. So would you guys say 14 or 15? 14 degrees. Okay. So we know that this angle here is 14 degrees. How would we find the angle in blue? Subtracted from 90? So we would say 90 minus 14 degrees would be what? 76 degrees. Okay. So y'all, remember what we're trying to find? We're trying to find the bearing. So we're trying to find the bearing for the return trip. Are we heading north or south? South. 76 degrees. Are we heading east or west? And we found it, right? Do you see how these problems are kind of building on each other, right? We knew we could find that green angle by using the tangent, and then once we find that angle, we can find the one we're really trying to find, and then we can use our bearing idea. Good, good, good. All right. So let's take a look at the next problem, y'all, and see if we can figure this one out the same way. Let's take a look here. And it says a plane leaves an airport at a bearing of north 38 degrees west and travels at 280 miles an hour for 2 hours. Okay, so first thing I'm gonna do, y'all, I'm gonna kind of draw a picture here. Okay, so we're heading north 38 degrees west. So I'm going in this direction. I know that this angle here is 38 degrees. And I need to figure out how far that distance is. So remember what we said, distance equals rate times time. So how fast are we going? 280. For how many hours? 2 hours. So 280 times 2? 560, right? Good. Thank you, John. 560. So we know that this distance right here is 560. Then the plane makes a 90-degree left turn. So look what happens. The plane does this number, right? 90 degrees. And it travels how many miles? 500. So we already know that this distance, y'all, is 500. Find the bearing required to locate the plane from the airport round to the nearest degree. Okay, so let's see what we're trying to find. We're looking for the bearing required to locate the plane. Look what it says. From the airport. So I'm looking for the bearing from this point here to that point there. Okay. And so a couple things we want to see if we can figure out. If we're looking for the bearing, remember the main angle we're trying to find, y'all, is this angle right here, right? And I know that since we're looking for the bearing from the airport to the plane, I know we're going in a north direction. And then because we're going slightly to the left, it's going to be north, some angle degrees west, right? What we need to find is we need to find that blue angle. But that blue angle is going to be 38 plus whatever this angle is. Do you think there's a way for us to find this red angle here? Couldn't we say the tangent, let's call this theta, couldn't we say the tangent is the opposite over the adjacent? So the tangent of theta, wouldn't that be 500 over 560? And then wouldn't we say that theta is the inverse tangent of 500 over 560? So let me grab my calculator again. Second tangent inverse of 500 over 560. And so that angle, would you guys say 41 or 42? 42, okay. So 42 degrees. And so we know that this angle right here, y'all, let me get rid of that. And let me get rid of this. Oh, I didn't want to get rid of that part, but it's okay. If we know that this angle right here is 42 degrees, and we're really trying to find that angle, what do we do with those two numbers? Add them together, so 42 and 38, 8. And we found it out. All right, good. What do you think? How do y'all feel about 6.1 so far? Pretty straightforward, not too bad? You're lost? Really? What part? Tell me. Oh, you're talking about like these here? Okay, so like the first one, number 7, I'm sure that was this one okay, number 7? Okay. Remember, I'm always trying to figure it out from the north-south line, right? So the angle that I'm trying to find is this one right here, right? Think about it this way. We already know that this angle is 124. Couldn't we find this little angle right here? How would I find that one? What's the whole thing going to be like this? 180. So we could say, look, 180 minus 124 is 56 degrees, right? So we would say, look, we know that this angle right here is 56 degrees. But remember, we want it to be, the angle we're looking for is the one with the north-south line. So couldn't we say, let's take 90 minus 56, and we'd come up with 34? So we did it slightly different. But remember, you're always looking for the angle, Thomas, on the north-south line, right? Same thing like when we did this one here. Remember, we're trying to find, we're trying to find this angle here. Well, we know that the one that they gave us was 220, and I think John was the one that said, look, wouldn't that whole angle be, how much, John, did you say it was? 270, right? So if I'm trying to find this angle right here, I'm going to say, let's take 270 minus 220. You see what I mean? So the part, guys, that you really got to remember is that the angle you're looking for is always the one on the north-south line, right? So even when I do this one here, I said, look, what's the angle I'm trying to find? This one. Well, we know the whole piece here would be 90, and if we know that piece is 19, that's what we subtracted, right? So I'll tell you what helps me, y'all, and I probably should have done this as we did this. Draw the line so that you know where you're going to measure your angle from. You know what I mean? Because then sometimes you're like, hold on, which one am I trying to figure out? What angle am I looking for? Yeah, no, I agree. I agree. It can get a little messy. All right, let's take a look at number 19. I'm trying to zoom in as much so we can see everything that's going on here. All right. Look what it says here. It says a boat is anchored off Elliott Key, Florida. From the bow of the boat, 36 feet of anchor line is out with 4 feet of line above the water. The angle that the line makes with the water is 22 degrees. How deep is the water round to the nearest foot? And then what is the horizontal distance between the anchor and the bow of the boat? Okay, so let's see if we can figure this thing out. Guys, I want to zoom in real closely because as I was doing this problem, I was making a mistake and then I realized what the mistake was. The 22, so look, first thing I'm going to do, I'm going to make this into a right triangle. I'm going to go like this, okay? Let me ask you a question. Where is the 22 degrees? Is y'all agree that the 22 degrees is that piece right there? Okay, so guys, think about it like this. If the 22 degrees is this part right here, isn't this angle also going to be 22 degrees? Okay, so look, think about it like this. What they're telling us is that this angle right here, you see what I mean? Yeah, this angle right here is 22 degrees. That's in this little tiny triangle. Well, then it's a similar triangle, right? This kind of triangle right here is the same type of a triangle. It's just a lot bigger than the red one. So that 22 degrees is right there. Does that make sense? Okay. Now, okay, but hold on. We're gonna go a little slower. Let me do this. Let me do this. Remember what it is we're trying to find from part A? From part A, we're looking for, where's part A? Here we go. How deep is the what? The water. So guys, is this what I'm looking for right now? But hold on. Okay, but think about it this way. What other one would I subtract? Remember, I'm not trying to find the whole piece. Aren't I really trying to find, oops, why is it doing that? So weird. Isn't this really what I'm looking for right here? This part? Okay, that's still 20, this is still, angle is still 22 degrees, right? Okay, didn't we know how long the anchor line is? Why is it doing that? It's so weird. Yeah, we know that the whole anchor line is 36. So wouldn't this piece here be 32? Because the whole thing is going to be 36. And if 4 feet of it is sticking out the water, wouldn't the rest have to be 32? I'm just doing 36 minus 4. Okay, let me ask you all a question. How would I find this given what we have? Okay, we could say the sine of 22 is equal to, or yeah, 22, I'm sorry. Okay, let's call this distance here y. Why is it doing that? That's so weird. Y over what, 32? Okay. So then we're going to say 32 sine of 22 is equal to y. I'm going to zoom out. I don't know if that's why it's doing that. Okay. And let's see. Let me grab my calculator right here. And we'll say 32 sine of 22. And if we're going to round to the nearest foot, what would you say? 12. 12 feet. Boom, there we go. So we know the depth of the water is 12 feet. All right, part B says, what is the horizontal distance between the anchor and the bow of the boat? Okay, so the horizontal distance between the anchor, here's the anchor, and the bow of the boat right here. This is what we're trying to find now, y'all. Okay. Y'all agree that this distance here was really 36, the whole thing? Okay. So if we're trying to find this distance here in the red and we know that this angle down here was 22 degrees, right? What trig function could we use that describes the adjacent over the hypotenuse? Cosine, very good. So we know the cosine of 22 degrees is equal to the adjacent, I'm going to call that x, y'all, over the hypotenuse, but the whole hypotenuse is really how much? 36, good. Okay. So then again, if we multiply both sides by 36, this is going to tell me 36 times the cosine of 22 degrees is equal to my distance x. Okay. And so again, we'll pull up our calculator and we'll go 36 cosine of 22 degrees. And that distance to the nearest foot, would you say 33 or 34? 33, right? 30, excuse me, 33 feet, right? So, one thing I want to mention about this problem, y'all, was that the other one seemed a little bit more straightforward. There were, the only one I think where we had to do a little bit of work was, remember the one where we were trying to find the height of the length of the window, and we had to do tangent twice, and then we subtracted. We kind of had to do something like that here in the sense that we had to draw a second triangle from only the part of the anchor line that was in the water, so we could find the depth of that water. You know what I mean? So we kind of had to do a little bit of extra work in this one to do that part, but we're able to do it. Again, the point that I'm really trying to make here is, in doing these problems, take your time with them, okay? They're not really all that difficult. They just take some time to do. And I think I got one more to do here. Here we go. And let's see if we can't figure out this problem. So let's see. It says an airplane climbs at an angle of 11 degrees at an average of 420 miles an hour. Excuse me. Find how long it will take for the plane to reach its cruising altitude of 6.5 miles, round to the nearest minute. All right. Look what we're trying to figure out here, y'all. How what? So how long it will take? Are we asking for distance, rate, or time? Time, right? Because how long is it going to take? That's something we were looking for time, right? So remember, my basic distance equation, y'all, is distance equals rate times time, okay? So let's take a look at what's going on here. It says a plane is climbing at an average, at 11 degrees at an average speed of 420 miles an hour. Okay, so here's my plane. It's going at 11 degrees, okay? So this angle right here is 11 degrees. We want to know how long it's going to take for the distance to reach a cruising altitude of 6.5 miles. Isn't that telling me that this piece here is going to be 6.5? Right? That'll be our cruising altitude of 6.5 miles. Okay. So let me ask you a question. Is there, suppose I call this D. Is there a trig function that relates the opposite and the hypotenuse? Sine? So couldn't we say the sine of 11 degrees is equal to D, or not D, but 6.5 over D? Okay. And then if we were to multiply both sides by the letter D, we would have D times the sine of 11 degrees is equal to 6.5. Okay. And then we could divide both sides by the sine of 11 degrees. And we'd end up with, grab my calculator, let me move it over here. So look what we're going to do, y'all. We're going to turn this thing on, clear it out. We're going to go 6.5 divided by the sine of 11. And that distance is, would you say 34 miles or 35 miles? 34 miles, right? Okay. So we found this distance here to be 34 miles. But remember what the question was asking us to find? The question was asking us for how long was it going to take, right? Okay, so remember, we had our distance equation right here. We said distance equals rate times time. The distance we already knew was 34 miles. Do we know how fast the plane was traveling? 420 miles an hour. How long was it driving or flying? We don't know. That's what we're going to find. Wouldn't we solve this, excuse me, by just dividing both sides by 420? So we're going to go 34 divided by 420. And to a decimal, I'm coming up with that number right there, 0.08095. I'm just going to write it right here, 0.08095. And I'm going to look at is it asking me to round to anything? Round to the nearest what? Minute. Okay. So guys, it was 420 miles an hour. So this is my time in hours. If we wanted to find our time in minutes, wouldn't we have to take that number and multiply it by 60, right? So right here, I'm just going to go times 60. And if you round that to the nearest whole number, would you say 4 or 5? So it's going to take us 5 minutes to get to that 6.5 mile cruising altitude. Again, if you notice, had to do a little bit of work in this problem to kind of get to my answer right, but we're able to figure it out. All right, so let me do this now, you all. Let me come back here. And let's go like this. And that's not what I want. Here we go. Let me come to Alex so that we can now finish up the questions we had reviewing. So let me come back over here. Review. Enter this in. Do that. Your assignment list. And review for the test. That's pretty fast, isn't it? Okay. So guys, the last one we did on Wednesday was 21. That was the last problem that we ended up doing that day. So let me click on 22 and just ask you guys if you have any questions on how to do 22. Anybody want me to go through 22? You guys let me know. Anybody?